For softening, we use pellet reactors because of its efficiency and the possibilities to reuse the waste product. The total area of the softening reactors depends on the minimum and maximum velocity allowed, being between 70 and 100 meters an hour. Although the total flow is 1000 cubic meter an hour, part of the flow can be bypassed when magnesium concentrations are relatively low. The bypass ratio can be calculated when assuming that the maximum softening depth in the reactor is 0.5 millimole per liter calcium. When the magnesium concentration is 0.25 millimole per liter, and it's not being removed during softening, the maximum bypass ratio can be calculated. So the total flow minus the bypass flow times the calcium concentration and magnesium concentration, and in addition the bypass flow times the total hardness is the total flow times the aimed hardness. So the total flow minus the bypass flow times 0.5 millimole per liter of calcium, in addition to 0.25 millimole per liter of magnesium. That's the Q1 times the total hardness, which was 2.5 millimole per liter, is the total flow times the aimed flow, which is in this case 1.5 millimole per liter. So solving this equation, is equal total times 1.5. So 1.75 times the bypass flow equals 0.75 times the total flow. So divided by the total flow, 0.75 divided 0.1.75 is, so the bypass flow is 0.43 of the total flow. So the flow to be softened will then be the 1000 cubic meter an hour times 1 minus the bypass flow, which is 570 cubic meter an hour. If we take a flow of 80 meter an hour, so here we assume 80 meter an hour, then this means a surface area of 570 cubic meter an hour, 507 T cubic meter per hour divided by 80 meters an hour, then the surface area is 7.1 square meter in total. The total height of a softening reactor is about 6 to 7 meters. And this is when caustic soda is used. In case of lime dosing, the height must be even higher. And to be flexible during operation, a minimum of 3 reactors should be installed. Because the flow is small, we can take this minimum in this design. The diameter of one reactor will then be 1/4 is the total surface area divided by the total surface area 7.1 divided by 3 reactors, and then we come to a diameter per reactor of 1.7 meter. The hydraulic resistance over the pellet reactor depends on the amount of sand and pellets that are in the reactor. When river sand is used, the resistance of a fluidized bed is equal to the height of the bed when not fluidized. The hydraulic resistance can be calculated with the formulas for backwashing of filters and can go up to 2 to 3 meters. Filtration is the next step and will be explained in the next movie.